Okay, well, hello everyone, and welcome to the Crucible Final Pitch competition. Today marks the culmination of months of work inside the Crucible Innovation Program, a unique collaboration powered by FedTech and delivered in partnership with NavalX and the Inland Empire Tech Bridge. Crucible exists to transform ideas into mission-ready ventures, supporting both the defense community and local innovation ecosystems. What you're going to see today are the top performing startup teams from two of our Crucible programs, Igniter and Accelerator, taking the stage to compete for a share of $250,000. These teams represent the very best of dual-use innovation, and today you get a front row seat to see their progress. My name is Brady Ryan, and I'm the Navy Innovation Lead at FedTech. Jacob Minima, Skill Bridge Fellow at FedTech, and I will be your MCs here today, and it's a privilege to help guide everyone through a day of cutting-edge technology, bold ideas, and real solutions to national challenges. We have an exciting agenda ahead. You'll hear opening remarks from our key partners, see startup pitches from the top performers from our two Crucible cohorts, and help us celebrate some outstanding innovators during our award ceremony this afternoon. Before we go further, I want to take a moment to acknowledge our incredible partners. NavalX and its national network of tech bridges are transforming how the Department of the Navy works with innovators. These teams are creating regional hubs for collaboration and experimentation, and the Inland Empire Tech Bridge has been at the heart of making Crucible possible. Together with NavC, they've championed a vision for dual-use innovation, empowering new technologies to solve both defense and commercial problems. We're honored to work alongside them. FedTech is proud to support this mission. Our work sits at the intersection of entrepreneurship, breakthrough federal R&D, and national impact. From startup studios to accelerators and beyond, we help bold teams turn powerful ideas into real-world ventures. We're here today not just as a partner, but as a community builder, connecting entrepreneurs with mission needs that truly matter. We're honored to begin today's program with pre-recorded remarks from two distinguished members of Congress, Congressman Ken Calvert and Congresswoman Betty McCollum. Congressman Calvert represents California's 41st District, home to the Naval Surface Warfare Center Corona Division and the NavalX Inland Empire Tech Bridge. He has been a longtime champion of innovation, defense modernization, and public-private collaboration. As a senior member of the House Appropriations Committee, he has played a critical role in advancing efforts that connect cutting-edge technology with mission needs. His leadership has helped make programs like Crucible a reality, and we are deeply grateful for his support. Congressman Calvert understands that national security is a bipartisan priority and that innovation must remain at the heart of our national defense strategy. Congresswoman Betty McCollum represents Minnesota's 4th District. As the lead Democrat on the House Defense Appropriations Subcommittee, Congresswoman McCollum brings decades of experience shaping national security investments. She's a strong advocate for innovation, service member readiness, and responsible defense spending. Her leadership reflects a broader commitment to building a modern, ethical, and resilient national defense. Together, these two leaders represent the foundation behind programs like Crucible, and we're honored to have their voices included in today's event.
Hello, I'm Congressman Ken Calvert, and I'm honored to serve as the chairman of the Defense Appropriations Subcommittee. I'm happy to be joined by my good friend and colleague, Congresswoman Betty McCollum, who serves as the ranking member of the Defense Appropriations Subcommittee. When it comes to national security, Betty and I are in lockstep agreement that a key component of maintaining America's military superiority is leveraging our technological innovation into a competitive advantage on the battlefield. From California to Minnesota and throughout our great country, the talent and ingenuity of the American people is on display every single day. We're working together to harness that innovation, help it grow to create jobs, as well as strengthen the defense of our country.
I agree with Chairman. We must prioritize and modernize our force and support investments which will support the future of modern combat. Together with our Defense Subcommittee colleagues, Chairman Calvert and I have provided critical investments in programs and initiatives to support innovators. We've helped grow the successful Defense Innovation Unit, or DIU, which is working to accelerate the adoption of commercial technology throughout the military. We've also provided funding for the first domestic manufacturing loan program run by the Office of Strategic Capital to help scale domestic manufacturing of technologies vital to our national and economic security. The national security challenges we will continue to face around the world only underscores the importance of these investments and rapid adoption of new technologies in all aspects of our military.
Words like disruption and innovation are being used more and more in the defense space. We must continue to build on this momentum. If we're going to truly cause the disruption we need and put our country on a new national security path forward, it's going to take all of us working together. I'm thankful for the partnership I have with Ranking Member McCollum, and I certainly look forward to working together with all of you.
Next, I'm pleased to announce Troy Clark, Director of the Inland Empire Tech Bridge. Troy has been a central force behind Crucible's development. His leadership helped shape this program into a national model for innovation acceleration. Let's hear from him now.
Thank you, Brady. Hey, good morning or afternoon, depending on where your time zone is. It's great to have you join us for our second annual Crucible pitch competition. It's hard to believe we're here. Crucible started as an idea with my colleague Jennifer Stewart and me 5 years ago, right at the time COVID hit. And Crucible sat on the shelf for 3 years with no funding, but I kept the dream alive, and thanks to Chairman Calvert's strong support of Tech Bridges and our advocacy for defense innovation, we are here in our second year and well on our way to a sustained innovation accelerator that's moving defense capability one step further to our warfighters for battle space advantage. Each one of these challenge statements comes, and that's on the next slide there, Brady. There you go. Each one of these challenge statements comes from either warfighter needs or regional community needs that have military use cases. Our warfighter needs are sourced by NavalX from the fleet and force to give our sailors and Marines the advantage as we outpace our adversaries. But each has a dual use purpose to benefit both our national security and our economic prosperity, because those two are interconnected and interdependent. The dual use approach that NavalX takes, it really expands the market for useful technology and ultimately accelerates its development by attracting investors, leveraging economies of scale, accelerating development, and lowering production costs. And we know dual use technology works. Radar, GPS, and the internet all started as defense technology decades ago, and look now how much they've benefited our everyday lives today. By participating in Crucible, you have a front row seat to the exciting world of defense innovation and are helping make our nation safer and more prosperous. And then next slide. And when we launched the Crucible pilot last year, I learned a lot about the advantages you startup innovators face as you're trying to help us deliver game-changing capability to the Navy, Marines, and the Department of Defense. So I looked around for best practices around the defense innovation ecosystem and created new additional programs across the innovation pipeline to accelerate delivered capabilities. This deep tech journey you're on is not fast or an easy road. We're looking at 7 to 10 years of hardcore science and engineering to field new capability. Because of the threats we face, we have to accelerate that. And that's what we're trying to do with Crucible. I expanded it to a full spectrum suite of programs to help startups progress through the innovation pipeline and deliver capabilities to us faster. Last year, we started with just Startup Studio, Igniter, and Accelerator. And for year 2, I created Crucible Extractor to assist companies to get into the DoD test and experimentation events, provide wraparound technical and business services to help them iterate alongside end users to speed up the feedback loop. Created Afterburner to assist you in that last mile delivery of programs or of operation or programs of record, and then created Catalyst to provide technical and business advisory services anywhere along this innovation pipeline. And then created Disruptor as a scouting program to hunt for disruptive companies and technology that can inject anywhere in this innovation pipeline, and the corresponding Crucible program. Crucible 2.0 is an experiment in and of itself, and we're glad you're a part of it. And we hope Crucible 3.0 is going to be even better. The whole goal is to get capability delivered to our warfighters faster. That is foundational goal of NavalX and our tech bridges. Crucible is partnership between NavalX and our programming support contractors, FedTech and Matter Labs, and we thank them for their diligent efforts and hard work to help you succeed so our countries can succeed. To the FedTech team, I want to thank you personally for your hard work in bringing some amazing entrepreneurs, startups, and technology into this year's Igniter and Accelerator programs, and for putting together this Crucible pitch competition today. This is an exciting milestone for us all. And to our startups and entrepreneurs, I applaud your courage, your hard work, and your patriotism as we embark on this journey of defense innovation. Our warfighters and our nation need you, and we're excited to watch your pitches. Thank you.
Thank you, Troy. Thank you for your vision and your support throughout Crucible. This does not get done without you. There's more than just bragging rights on the line today. For this pitch competition, there's real money at stake. Igniter teams are competing for $50,000, $30,000, and $20,000 awards. Accelerator teams are competing for $75,000, $50,000, and $25,000 awards. That's $250,000 in total non-dilutive funding to help these teams scale their impact. We're joined today by a diverse panel of judges. These judges come from the network of Tech Bridges, DIU, AFWorks, and the broader DoD innovation ecosystem. They bring expertise in national security, technology transition, and venture building, and we're grateful for their time and insights as they evaluate these incredible teams. Our judges are Troy Clark, Marco Romani, Jack Ryan, Julie Calfels, James Fouts, Christopher Chase, and Rick Tarr. All teams will be judged on a shared rubric ensuring a fair and transparent evaluation process. Included in the rubric are program alignment, potential for mission impact, technical viability, and more. Each team will have 5 minutes to pitch, followed by 3 minutes of Q&A with the judges. Judges, we'll be moving quickly, so please finalize your scorecards right after each pitch. Before we dive into Igniter pitches, I want to take a moment to highlight what these teams have already accomplished. Over the past 14 weeks, these early stage ventures have dedicated 20 hours a week to the program, progressing through 2 rigorous phases: technology solution fit and venture formation. They've tested assumptions, built business models, and worked closely with FedTech coaches and DoD stakeholders. This year's Igniter cohort brought together 26 entrepreneurs across 10 new venture teams, and the outcomes speak for themselves. 2 teams, Superfoam and Aurelius Industries, were spun out of the Igniter 2024 cohort and admitted into this year's accelerator program. Superfoam also took home $150,000 at a regional pitch competition hosted by UCR. These results are a testament to what can happen when you combine emerging technologies with mission-aligned talent. We are incredibly proud of what this cohort has achieved. We'll begin today with our Igniter cohort. These early-stage ventures were built around technologies sourced from Navy and academic labs. Over the past 14 weeks, they've participated in FedTech's venture formation process, refining their mission, testing their assumptions, and exploring real-world use cases. What makes this unique is that these teams didn't exist before the program. We identified the technologies, recruited the entrepreneurs, and brought them together, forming brand new ventures from the ground up. These teams you'll hear from today were selected through an internal down selection process. They'll be presented in no particular order. Judges, when you're ready to ask a question in the Q&A, please come off mute. We'll begin today with solid hydrogen, pioneering clean energy through advanced hydrogen storage.
Imagine bottling lightning, not in myth, but in metal. I am Hassan Pasha, co-founder of Solid Hydrogen. Hydrogen is the future of clean combat-ready energy, but storage hasn't caught up. Pressure tanks are bulky, cryogenics are fragile, neither fits the battlefield. Our patented solid-state platform is safe, compact, and mission-ready. Our work aligns with the FedTech Crucible Challenge, sustainable infrastructure and green technologies. We've captured lightning in a bottle and we are ready to deploy it. The 2 trillion hydrogen economy is stalled, not from supply or demand, but from storage. High pressure gas is risky. Liquid hydrogen boils off. For the Navy, where silence and safety matter, that's a no-go. If we fix storage, hydrogen delivers. Our patented material, magnesium boride, locks hydrogen into a solid, stable form. No tanks, no cryo, just dense ambient temperature storage, which is proven and ready. We are commercializing it with the lab that invented it. We store the same hydrogen in a third of the space, meaning more range, more payload, and less infrastructure. This is perfect for USVs, submarines, and anywhere silence and space matter. After 100 plus interviews, one thing is clear. The Navy is moving toward 33% autonomy. Future platforms need silent propulsion, compact design, and safe refueling. We check every box. Our technology is silent because there is no combustion involved. It's modular and it fits tight platforms. It is also safe at sea because there are no tanks or cryogenics. It's not theoretical and it's pilot ready. We start with Mantis T12 and Devil Ray T24, platforms the Navy already knows. Each includes a solid state tank, fuel cell, and drive retrofit. We prove stealth, range, refueling, and then scale. Our edge is materials first. Magnesium boride delivers unmatched energy density, volumetric efficiency, and ambient stability. We also use AI to optimize next-gen variants, building a pipeline others can't match. We are entering the 100 million tactical USV segment, ideal for hydrogen. The Navy spends about 5 billion every year on fuel. Modular energy is already in motion. We start focused and scale across the fleet. Our model is lean. With 50% margin, we break even at 7,500 units, realistic in early Navy adoption. Fixed costs are covered by year 2 and 3 via SIBRs and pilots. From there, we scale with strong unit economics. Our path forward is clear. In 2025, we launch our Navy pilot and deliver the first prototype. In 2026, we roll out version 2 and pursue SIBR's phases 1 and 2. Then in 2027, we plan to raise our seed round, prepare for Series A, and begin pre-production with our partners. It's a focused roadmap from lab to fleet. We are a founding team built for this mission. I bring 20 plus years in clean tech and deep hardware. Arun leads AI-driven material discovery, and Cam drives defense go-to-market and engagement. Backed by Sandia, Argonne, and the University of Hawaii's DoD fuel cell groups, we are connected to both the mission and the market. We are builders who are aligned and move really fast. Hydrogen is a 2 trillion opportunity, but without safe storage, it cannot deliver. We've built a platform designed for defense, engineered for scale, and backed by patented science. We are raising 1 million to go from lab to launch. Join us in powering mission-critical energy. We have lightning in a bottle, and it's ready to deploy. Thank you very much.
Now, 3 minutes with our judges.
Yes, this is Jack Ryan with Defense Innovation Unit. I'm over in our energy portfolio, and we've got a few programs right now working around hydrogen, and we're very and acutely aware of the issues with storage of hydrogen. Can you speak to this solid form of being able to move in austere environments and rough terrain? Is there any threats to this, hardened form, coming apart? Have you done any lab testing on that at all yet?
Hi, Jack. I really appreciate your question, and I'm glad to be here today. First up, I apologize that my video was out of sync. I don't know what happened there. Solid hydrogen is actually very advantageous compared to how we store hydrogen currently. The way we store hydrogen currently is in gas form that requires really high pressure. And also, we can save it as liquid hydrogen, which requires really low temperatures. That means that we have to spend a lot of energy and there could be losses involved. In addition to that, both these forms require that we have to have a cylindrical storage unit. So that's not ideal for cases where we have very restricted environments. That would be very typical of DoD applications. So when we try to store hydrogen in a solid form, we use a material that has affinity to hydrogen. It absorbs the hydrogen and it releases it at some ideal temperature. That's the way we assess if the material is good. Our patented material, magnesium boride, not only has high capacity, but it releases hydrogen at a favorable temperature. It releases it at 300 degrees centigrade. What that means is there won't be any accidental release. And also 300 centigrade is at an optimum range. You don't have to spend really high energy to sustain the reaction. In most cases, there is waste heat involved, and we can use heat exchangers to actually extract and use that heat to sustain the reaction. So this technology has already been proven in the lab, and we are going to take it to real world applications by doing more testing and scaling it. Thank you.
Great. Thank you for that.
And hi, Dr. Pasha. My name is Julie Caulfield. I'm at the Naval Undersea Warfare Center here in Newport, Rhode Island. I have a related question to testing and just stability of your fuel cells. Have you or has the Navy, given this is written on a Mantis, has the Navy or another lab actually performed any kind of shock and vibration or heat extremes, temperature testing? And then in a related question, what would you anticipate the lifespan of these fuel cells to be? Thank you.
Thanks for the question. So this technology has been tested in the lab. The initial focus has been to prove the proof of concept, to prove that this material has very high capacity, and also we are able to kind of do the whole cycle, hydrogenation and dehydrogenation. So compared to the DoD targets for automotive industry, this material has more like close to 3% capacity, which is great. And this has been proven. However, more testing has to be done to test the scalability for real world applications. That's where we are partnering with national labs like Sandia National Lab, University of Hawaii's DoD Fuel Cell Department. We are working with them to actually prototype this and test so that we can get into pilot applications. I personally have a background in mechanical vibrations and structural dynamics, and also experience in automotive environment where I've done deep testing. So our team actually collectively has this experience where we can take this from the lab to real world applications.
Thank you.
Hi, good afternoon, Rick Tarr. A couple quick questions on the IP and your relationship with the University of Hawaii. Are there inventors on your team? Is the university still doing R&D around this technology? And have you licensed the technology? And if so, what are the terms? Have you been able to negotiate exclusive license, partially exclusive in certain fields, or that sort of thing?
Hi, Rick. Thank you for the question. We work really closely with our team at University of Hawaii. Dr. Godwin Savera, he was the inventor, and we meet regularly with him. He is going to be part of our advisory group. In addition, we are in touch with the University of Hawaii's Tech Transfer Group. We are exploring ways to license their technology. So we've had initial conversations. We are very close to incorporating. As soon as we do that, we are going to get a limited license to scale this technology and do some initial testing. In addition, Dr. Godwin Savera is already working with Sandia National Lab on a host of other related materials. And we've had preliminary discussions, and we are in the process of attaining collaborative agreements to work with both University of Hawaii as well as Sandia National Lab to use their testing facilities and leverage that to accelerate our progress.
Thank you.
Judges, thank you for your questions. We're going to move on now. to Carmine Minerals, delivering sustainable solutions for rare earth recovery.
Hi, I'm Jacqueline Jones, founder at Carmine Minerals. Lithium demand is skyrocketing. China controls 80% of global lithium supply. If they cut us off, our domestic reserves cover just 1% of the demand. Scaling up could take 2 decades. We just don't have that kind of time. Lithium is not just essential, it's a strategic vulnerability. It powers critical military systems like drones, guidance systems, and communications. Our national security depends on getting a reliable supply now. At Carmine Minerals, we have a solution. Our revolutionary technology extracts lithium from industrial waste streams in the United States, enabling us to meet our own lithium demand. We use a highly selective binding agent that works like a magnet. We extract lithium from waste streams that were previously too costly. Unlike other direct lithium extraction methods, or DLE, we can extract lithium from solutions with concentrations lower than 200 milligrams per liter, like those from desalination plants, oil and gas fields, and solution mining operations. In short, we unlock lithium from existing sources that are uncompetitive for others.
Hi, I'm Raymond Moorhead Jr., founder at Carmine Minerals. Our technology stands out because it simplifies the lithium extraction process. Unlike major players, we don't require pre-processing to remove other minerals. This reduces our steps by 50%, leading to a 30% lower cost compared to our nearest DLE competitors. We're extracting lithium at under $3,000 per ton. We have reduced water use by 75% and energy by 50% compared to hard rock mining, which still runs at about $7,000 to $8,000 per ton.
Our liquid extraction system is turnkey. It enables seamlessly into existing operations with minimal disruption. It's an easy addition after your primary process. The result is an estimated 10x return on investment.
Now, the global lithium market is expected to grow from $27 billion in 2024 to $134 billion by 2032. That is a whopping 22% compound annual growth rate. Our addressable market includes the U.S. lithium market and expanding into existing brine-based mining operations worldwide. Even with conservative estimates, our attainable market exceeds $750 million. But what truly sets us apart is that our technology isn't limited to just lithium. It can also extract other critical minerals like magnesium, sodium, and uranium. Over the next 5 years, our go-to-market plan will have 2 phases. In the initial partner installation phase, we will begin targeting early-stage mining companies in Southern California. With these early adopters and equipment manufacturers, we will be performing trials and developing our minimum viable products. In the public launch phase, we will pursue industries that already generate high-volume brine waste streams and are actively seeking more sustainable solutions. We project to be cash flow positive by year 5.
We are a team of seasoned professionals with the business acumen and technical expertise to bring this to market. I have over 20 years experience in the energy sector and know how to navigate complex industries, scale innovation, and deliver results.
I bring over 6 years of experience in driving growth for startups through strategic marketing and customer acquisition. Dr. Anna Long, who's also the tech transfer officer, often says, "Your win is our win." And our inventor, Dr. Kimberly Cousins, has over 30 years of experience in chemistry, blending creativity with practical problem solving. But it's not just about our expertise. It's about the ecosystem that's supporting us. We're deeply connected to CSUSB as trusted partners in innovation. We're also building strong industrial partnerships, including our beachhead customer, facilities near the Salton Sea, and experts in process scaling.
Right now, we are asking for $500,000. 50% will be used for cost share for grants, 40% for equipment and material expenses for testing, and 10% for new IP. In the partner installation phase, we plan to raise $3.5 million by leveraging non-dilutive sources like competitions and grants. And in 2028, we are considering a Series A for $2 million to fund our demonstration plan. National security depends on critical minerals. Let's strengthen America's lithium supply together. I'm Jacqueline Jones with Raymond Moorhead Jr. from Carmine Minerals, where waste is the future of energy.
Now, just 3 quick minutes with our judges.
Yeah, well, quickly, this is Marco Romani. Curious, you mentioned a couple of times partnering. Where are you guys in, like, the spectrum of actually setting up any partnerships with potential waste stream, partners that would have waste streams?
We have one partner that's extremely interested, a local boron miner who's interested in the magnesium extraction process predominantly, but also the lithium extraction as well.
Hey, Jacqueline, it's Troy. How are you? Hey, so quick question. How tunable is the technology for those other specific minerals? That's my first part of my question. Then second, what are your prospects of working with lithium battery recycling? That's a huge problem right now.
Excuse me, I'm sorry. Our technology can be adapted. It's still in a research phase for minerals, and we definitely can do the recycling. There's a licensing issue around that we would have to deal with, but that's just a paperwork thing, right? Paperwork and negotiation.
All right, thank you.
And with that, judges, please take 60 seconds to fill out your scorecards. Moving on to EcoHive, harnessing carbon for energy-efficient infrastructure.
Hi, I'm Kalakino, CEO of EcoHive, where we harness CO2 for efficient energy storage. Renewable energy is the future, but for utility companies, it's unreliable. Solar and wind power fluctuate, making it very difficult to depend on as a consistent energy source. That's why energy storage is critical. But today's solutions, they fall short. The industry is stuck with options that just don't scale. They're costly, relying on scarce and expensive rare metals. They're unscalable, with short lifespans that require massive infrastructure. And they're unsustainable, creating bottlenecks that slow the widespread adoption of clean energy. If we want renewables to be a truly dominant energy source, we need a better way to store energy. That's where we come in. EcoHive will revolutionize renewable energy storage, enabling global adoption of sustainable power. We do this through our CO2 formate flow battery. This is a major breakthrough in energy storage. We've already reached TRL4 and secured a patent at UC Irvine. We're economical, cutting costs by removing vanadium and lithium dependency. We're also scalable with a modular design and high energy density. And we're sustainable, turning CO2 into a clean, efficient energy carrier. This isn't just another battery. It's a smarter way to store energy. This is how our tech works. First, renewable energy, like solar, is collected. Next, CO2 is converted into formate, charging the battery. Our key differentiator here is this: our low usage of rare metals, making us more economical and sustainable. The stored energy lasts 8 to 12 hours, and when the energy is needed, the formate efficiently converts back into CO2, thus providing continuous energy flow 24/7. Of all the other redox flow batteries, we are the most efficient, the most scalable, and dramatically less expensive. Even Agora, our closest competitor, they rely on palladium, which is not as efficient. EcoHive isn't just better, it's the most cost-effective solution on the market. For pilots and early customers, we offer a flexible OpEx model, which is aligned with industry norms at just $15 per kilowatt hour per month, enabling companies to deploy without heavy upfront costs and begin adoption immediately. Our go-to-market strategy begins with utilities and renewable energy developers on the West Coast. Phase 1 is early pilots and catalyst validation. Phase 2 is scaling pilots and advancing to TRL5. And Phase 3 is full commercialization and dual-use market expansion. As for dual use, EcoHive can effectively stabilize and protect microgrids in bases both at home and abroad, especially those stood up by the Navy and Marine Corps. So far, we made solid progress in our customer discovery, applied for non-dilutive funding, and of our live opportunities, we've had the most traction with the Imperial Irrigation District for potential pilots and the Naval Postgraduate School for a potential CRADA. By focusing on utilities and renewable energy developers, we're on track to reach 5 million ARR in just 3 years through our OpEx model alone. Each customer represents a 2 megawatt system with an ACV of $360K, meaning we only need 15 companies to hit that milestone. We're entering the energy storage market, which is worth $52 billion and is set to double in the next 5 years, growing at a 14% CAGR. And EcoHive is perfectly positioned to go capture it. We have the right team in place to make it happen. Andrew is the CSO and co-inventor with deep technical expertise. Jenny is the primary inventor and advisor who's also the leading expert in CO2 electroreduction. And I'm Kyle, a former naval officer and 3-time B2B SaaS CEO leading commercialization. Together, we bring an unfair advantage to dominate the market and win. Right now, we're raising $2 million to take EcoHive to the next level. This gives us an 18-month runway to advance our catalyst development, advance to TRL5, and set up for a seed round in 8 to 10 months. This isn't just an investment, it's an opportunity to build the future of energy storage. Let's make it happen together. Thank you.
Now, 3 minutes with our judges.
Hey, Kyle, quickly on the founders that you showed on the other slide, are they all preparing to like leave their day jobs? Are they coming on full time, or I'm just curious what their commitment is to the company?
Well, I'll let Andrew, our co-inventor, CSO, answer that.
Yeah, so I still currently work for the inventor, trying to improve this technology. And if we get funding for EcoHive, I definitely plan to stay on.
Hey, Kyle, it's Troy. Hey, so quick question. What are the specific challenges or requirements that you're facing with these early adopters? And then, what's your plan for expanding into dual use market on military bases?
Yeah, absolutely. Some of the earliest challenges that we're facing is managing the whole go-to-market with where we are TRL-wise with the technology, since it's still at lab scale. Especially engaging with potential partners like, say, IID, like my local power company out here. Even for them to engage in further on discussions, I could tell that they're taking a huge leap of faith moving forward with that, knowing that where we are currently. But a lot of the discussions were more like wanting to de-risk more around TRL6 or more in order to want to do something either out of a smaller scale. So it's really a lot of that managing piece. And in terms of with the military, we're hoping that our engagement with NPS, Naval Postgraduate School, that we hope that that's going to turn into a very fruitful relationship. So right now they're proposing LP CRADA with us. They want us to provide um, another prototype for them to already use. So they're already wanting to test this out. We have those champions already in house, and we just have to create one, ship it out to them for them to test, and then we're hoping that actually they were even offering that we would be co-writing grants together to already start getting even additional funding or even more additional traction already into the DoD outside of SBIRS. And of course, we're going to be applying for SBIRS as well.
Hey,
Excellent. Thank you.
Quick question. Understanding using, renewables like solar to be the initiator. How small of a form factor in creating a mobile platform where you don't have access to a wide swath of, solar panels, where you need to carry it on a vehicle or, a trailer of some sort? How small can you go and still create, or store enough power?
Over to Andrew.
Yeah, so we haven't looked too closely into, say, like small vehicle applications. These types of redox flow batteries are usually more suited for the type of grid scale storage solutions. So that has been our main point of focus.
Thank you.
Thank you, judges, for your questions. Please take 60 seconds to fill out your scorecards.
Thank you, everybody.
Next up, SHIELD, developing advanced detection tools for hazardous environments.
I'm going to start by mentioning an incident that occurred a little over a year ago at Langley Air Force Base in Virginia. Langley experienced a series of mysterious drone incursions which it was unprepared to confront. The base's advanced aircraft and intelligence capabilities make it a cornerstone of U.S. air power and defense. This incursion constitutes a grave threat to national security. I'm Olivia, and I'm joined by my teammates Andres and John. Together, we are SHIELD, offering smart horizon intrusion enforcement with laser detection. The Langley drone incursions are so public and urgent that they were featured in a recent episode of 60 Minutes. Air Force leadership emphasized that there is no current suitable way to detect or respond to these incursions. It is crucial to close gaps in detection and mitigation of these threats. SHIELD will do so by detecting, locating, and identifying objects crossing a defined perimeter. This perimeter will be a laser wall paired to optical detectors exclusively sensitive to wall crossings. Our solution offers not only early detection and 24/7 all-weather operation, but also low false alarm rates and scalable implementation. We eliminate gaps in current systems uncovered during customer discovery, high false alarm rates, and burdensome operator intervention. SHIELD provides situational awareness and perimeter security, yielding efficient hardware and human resource use. How do we do it? The key is our inventor's breakthrough laser detection method, which distinguishes scattered laser light from other environment light extremely sensitively. It is so sensitive that it can measure the minute amount of laser light that bounces off of centimeter-scale objects, like drones, in all directions when they cross a laser beam. The scattering is dependent of drone characteristics, which allows object identification through signal processing. A complete shield system will incorporate laser sheets to define a perimeter with very wide instantaneous field of regard and microsecond response, as well as immunity to electromagnetic interference and background clutter. Shield will provide integrated hardware and software solutions for aerial perimeter monitoring, integrated into current command and control solutions. We will charge for hardware with recurring maintenance contracts, as well as software customization and integration with recurring software licensing. Our patent-pending technology has grown from DARPA and NSF-funded projects. Our commercial focus will be the U.S. market, and we will initially address defense and homeland security needs. Customer discovery confirms that approximately 1,200 military installations in the U.S. require small drone detection capability. Our interviews with Air Force stakeholders indicate that deploying our solution at a facility like MacDill Air Force Base for a cost around $1 million would be immediately desirable. Within 2 years, we will demonstrate SHIELD, accelerating toward operational deployment by year 5. Solutions do exist for this problem, but pose various challenges that our solution mitigates. Unlike existing solutions, SHIELD rejects background clutter using balanced coherent detection, eliminating false alarms. Our implementation also provides a wide, yet directionally sensitive, instantaneous field of view. SHIELD is sensitive to small targets, smaller targets than radar is fundamentally capable of detecting. We are also sensitive to passively guided drones that have no radio frequency emissions, and lastly, our SWAP enables fixed or mobile implementations. Our team assembled organically. We are a group of scientists tackling technology development from different perspectives. Andres has started a handful of companies in deep medical and consumer technology, building teams to integrate hardware with complex software analysis. He has multiple commercial exits totaling more than $100 million. I'm Olivia, and I'm an expert in optical sensing, from fundamental quantum measurements at USC to development of operational systems at NASA Jet Propulsion Lab. I will lead SHIELD system design, prototyping, and demonstration en route to validation in customer environments. Jonathan is a faculty member in the Viterbi School of Engineering at USC. He brings 2 decades of experience developing novel solutions to problems of national security and leading DARPA programs to realize those solutions and support their transition. His invention underpins our solution, and he will serve as the head of the scientific advisory board. SHIELD is looking for seed-level funding to advance our technology to address this national security crisis. As part of that, we seek introductions to counter-drone programs in the armed forces and homeland security. This will help us align needs with development targets and timelines. Thank you for your time.
Now, 3 minutes with our judges.
Hi, it's Julie Caulfield here at the Undersea Warfare Center in Newport, Rhode Island. I'm wondering if you have done any analysis or even prototyping of a rendition of SHIELD that might look at surface-based, afloat surface-based drones and kind of that air-water interface and managing scatter and that environment. Over.
I'll direct that question to John.
Thank you for that really interesting question. So we actually haven't done any experimentation on targets that would be floating in the water, but all of our analyses thus far have been atmospheric. And so it would be really interesting to put a water model into the signal that would be coming into the receiver and show that we could differentiate the characteristics of a drone from the reflections from the waves and things like that. Thank you.
Hi, this is Rick Tarr from Southern Marin Tech Bridge. Can you talk more about how you're generating the laser sheets and the illuminators they're using? And I'd assume you'd need multiple illuminators. You know, if you were looking at a 5-mile sheet to put up, how many hardware illuminators would you need to be able to do that? Over.
John, do you want to take that question as well?
Yeah, sure thing. So I think this is one of the things we're most excited about with Shield is that what we've demonstrated in the lab is we can work with all kinds of configurations between the light shields and the sensor. So given a particular installation, we can come up with a custom arrangement for the optical fence and a custom arrangement for where we put the sensors. What we're thinking, we did an analysis for MacDill Air Force Base in Florida, and we believe that a light post, an optical sheet, about every kilometer makes sense. But for each different scenario, we would look at it and come up with a custom solution.
Well, curious, does it matter what kind of, because I'm not sure quite exactly how you're detecting, like, are you getting reflection off of like rotor blades, or does it matter what the propulsion is, or is it just as long as it's airborne, you're able to detect it? And if that's the case, how to differentiate between like birds or other types of items? And oh, by the way, fight on, my daughter's a Perturby grad, so by the way.
Okay. Right on. So that's an awesome question. And the key there is in the signal processing at the output of the detector. So we can really differentiate different targets like birds and, even things like a leaf crossing the path by the characteristics that we see in the Doppler shifted return from the optics. So we can pick up on rotor blades and differentiate that from other benign targets that would be crossing the laser fence. Awesome question.
Thank you, judges, for those questions. Please take a minute to fill out your scorecards. Up last is Ambient Sense Technologies, advancing environmental sensing for operational awareness.
We are Ambient Sense Technologies. Our first product, Smart Stickers, are a simple, inexpensive solution to monitor corrosion. Let's talk about rust. It's always in the background, but rarely treated as high priority. Instead, it tends to creep up on us until something fails. And that's exactly what happens in industries all across the globe. Corrosion is a complicated, pervasive, expensive problem. The global cost of corrosion is $2.5 trillion. To put that in perspective, corrosion will cost the world $24 million in just the 5 minutes we spend on this presentation. The Navy alone spends $7 billion a year on corrosion, operating in the harshest saltwater conditions. And the scary thing is, we don't really have great ways to manage corrosion. Monitoring remains an underutilized resource due to the expense and difficulty of data retrieval. Lack of real data in field conditions leads to inaccurate models, yielding either excessive maintenance or unexpected system failures. Smart stickers will be a significant step forward in better managing corrosion by providing actionable insights to protect, monitor, and maintain valuable systems. The idea for the smart stickers came from Naiwek Pak, where the chief engineer of the Restore Lab is relentlessly focused on how to maintain naval systems. His observation around the lack of good corrosion monitoring led to the creation of a better solution. At a high level, the smart stickers are RFID tags that monitor atmospheric corrosion trends. They're small and inexpensive enough to stick anywhere and allow data to be easily gathered. The smart stickers expose 3 copper wires of increasing diameter and measure their resistance. As the wires become corroded and fail, resistance increases, matching the rate of corrosion. Sailors can read the data using a standard RFID reader, powering the circuit and allowing the sticker to run without a battery. Scanning can be easily incorporated into existing naval inspection schedules. Cost at scale would be less than $5 a piece, allowing them to be widely deployed. The first version of the stickers will be passive for ease of military deployment, but later versions will be active for continuous gathering and transmission of data. The global corrosion monitoring market is estimated to grow to 880 million by 2032. From over 60 customer discovery calls, we'll target 3 initial use cases. Corrosion significantly impacts equipment and storage. Monitoring leads to optimized equipment checks and avoiding system failures. Military and civilian services rely on site severity designations to set maintenance schedules. Site and vehicle-specific monitoring will optimize maintenance. Corrosion under insulation refers to hot metal pipes with insulation. Moisture trapped by the insulation causes corrosion to the exterior of the pipes, which is difficult to detect. Step 1 of our business model is to develop reliable corrosion sensors and prove their accuracy in measuring corrosion trends. Having a large data set will then enable us to create a new generation of AI-based predictive models that will revolutionize the world's ability to manage corrosion. This results in 3 streams of revenue: the sensors themselves, the AI-based predictive models, and consulting around monitoring solutions. We're targeting both military and civilian applications. Several organizations are interested in piloting the smart stickers, including the Air Force Corrosion Office, a Marine Corps depot, the Salt River Project, and the Ultra Energy Group. Smart stickers are unique and differentiated by their cost and ease of use. With other sensors, customers tell us they buy only a few sensors and then move them around to gather measurements. Metal corrosion coupons are an inexpensive alternative, but very labor intensive. The current market is also missing data-based predictive models. Smart stickers are designed to be scalable, allowing customers to easily generate much more data. Our team brings deep expertise in entrepreneurship, Internet of Things, data modeling, and corrosion engineering. I'm the CEO and was previously a vice president in Internet of Things at Intel. Kiernan is a serial entrepreneur focusing on strategy and operations consulting. He's our CFO and Chief Strategy Officer. Brian is our CTO and COO. He oversaw software engineering for Yahoo Search advertising and is a successful software entrepreneur. Stephen Cox is our technical advisor. He's a chief engineer at NavalX and inventor of the smart stickers. His background includes naval systems and degrees in manufacturing engineering, math, and computer engineering. We project having viable prototypes in 2025 and revenue in 2028. The prototypes will be built through a custom RFID contract manufacturer, allowing us to start quickly and then easily shift to scale manufacturing without significant capital. To estimate revenue, we take the 580 million monitoring market in 2029 and assume we'll replace 50% of corrosion coupons, yielding a revenue sum of 46 million. Our ask is simple: connect us to people interested in monitoring and preventing corrosion and leads on funding opportunities. Thank you.
Now, 3 minutes with our judges.
Hey, Mandy, this is Troy Clark with the Inland Empire Tech Bridge. One of the things, our command is one of our mission sets is measurement science and calibration. So how accurately did the copper wire measurements correlate with the actual material loss? And can you calibrate that for different materials, say, steel hull for ship or aluminum for an airplane? Thank you.
Hey, Troy, that's a great question. Thank you. Let me hand it to Brian, our CTO, who will tackle that one.
Thanks, Troy. That is a great question. Originally, we're going to go ahead and work with copper. We've gone ahead and looked into using other materials, but we don't have a good answer right now at TRL level 3. One of the research areas that we want to do is address different metals and go ahead and address different form factors. You also asked how sensitive it is. We can go ahead and see that it works in lab conditions, and we go ahead and have 3 different wires. They go ahead and break one after another. That's a very clear signal. The question really then becomes like, what will that go ahead and look like in the environment? And so along with the work that we're doing to go ahead and work on our CRADA with NavalX, we're also going to go ahead and be working with some commercial individuals, hopefully at the Salt River Project, for example, to go ahead and get some samples into real world environments. And we'll have better answers for it once we get that done.
That's great. And hi, it's Julie Caulfields at the Northeast Tech Bridge here at the Undersea Warfare Center in Newport, Rhode Island. So we actually have folks on our staff we call Dr. Rust and things like that. So corrosion obviously is of a lot of interest to us. It does sound like the prototype you have now is looking more at the environment, not necessarily the target metal, whether it's bronze, okay. So
That is
good.
correct. So specifically, like atmospheric corrosion is our concern, right? So
Understood.
you can kind of
Okay.
see how it came out of the Navy, for example, right? There was value there to go ahead and understand when you're in these salt-rich environments, what's happening in, say, like a computer room, right?
100%, and feed that into condition-based maintenance and all sorts of other ideally
That's correct.
predictive stuff.
Yes.
So great. Second question is around differentiation. You know, this is a very simple, very inexpensive kind of concept. How would you protect your market or try and differentiate as others undoubtedly pursue a similar, nice, elegant solution?
I think I'm
That's
going
a
to pitch that back to Mandy.
Thanks, Brian. That's a great question, Julie, and one that we've thought about quite a bit. We actually believe the sensors themselves are not our primary protective technology, although we do have the patent through NIWC PAC that we are licensing. But what we think the real intellectual property that we'll have is in the data models that we get out of this. One of the things that's happening in the market today is there's just not a lot of data out there. You know, Rust is so complicated. There's so many factors that go into it that it's hard to create a really good predictive model. What we will do is through inexpensive, scalable, and yet reliable RFID stickers, be able to scale the use of the sensors out there to dramatically increase the data that we have, which then can feed into AI predictive models, which can give us a better idea of what's actually happening with corrosion and how to prevent it or manage it better.
Great. Thank you.
Thank you, judges. Please take a minute to fill out your scorecards for all Igniter teams. Let's give a round of applause to our Igniter teams. We'll now take a short break. Judges, please use this time to finalize your scores. Everyone else will be back in 5 minutes for the Accelerator Pitch Competition. During this time, we'll be playing highlights from last year's Innovation Summit and playing a highlight and thank you reel of today's Crucible partners.
I'm delighted to see such a full room. Thank you so much for joining the first inaugural Inland Empire Innovation Summit. We're so thrilled to have you all here.
I think you're going to be inspired, you're going to be wowed. I've seen some of the practice sessions and it's incredible to see what these minds, these courageous entrepreneurs are doing and what they want to bring to bear for the DoD as well as the private sector.
This is the manifestation, I think, of years and years of effort. This is an overnight success, 20 years in the making.
And so I think if there's an important initiative that we're really all focused on in this room, it's how do we tell the story of not just the successes, but really the vision and the values of this region and how we're building on those.
American defense innovation is reawakening. From software to autonomy to space launch, non-defense enterprises have already fundamentally changed the way the department does business. I believe the innovation empire has the integral role to play in national security of our country, and I look forward to working with all of you to make our region home to the next tech revolution. Enjoy the summit, and God bless you, and God bless America. Thank you.
Welcome back. Now we move to the accelerator cohort, growth stage companies already working with government and industry partners. These teams are scaling into dual-use markets and expanding their impact. Now let's recognize the accomplishments of the Crucible Accelerator cohort. Over the course of 11 weeks, 15 startups from across the country participated in targeted programming designed to help them grow in both government and commercial markets. Through weekly workshops, they explored funding strategies, cyber pathways, DoD customer navigation, and engagement with the NavalX and TechBridge network. This type of program sets companies up for dual-use success. Since completing the program, last year's cohort members have raised more than $6.8 million in follow-on funding. StarNav secured both a SpaceWorks Cyber Phase 1 and a U.S. Army Phase 2. Genesis Systems successfully delivered its first water cube unit to DevCom ARL. These milestones demonstrate how accelerator teams are already making an impact, not just with innovation, but with real traction in national security missions. These logos represent the full accelerator cohort, 15 startups from across the country, all working to grow their footprint in national security and commercial markets. Each team brought unique capabilities to the table, and we're proud to recognize the full cohort here today. First up, Hydron Technologies, advancing hydrogen fuel infrastructure.
We are Hydron, and we have a new composites manufacturing process that will revolutionize lightweight component production with many DoD applications. The industry chooses composites for their lightweight, high strength, and corrosion resistance, which allows entire systems to achieve increased performance, fuel and energy savings, and decreased emissions. The problem is that producing complex parts with composites is very difficult. Traditional manufacturing involves placing each layer by hand, one by one, and this process is difficult to scale with high costs, low throughput, and defects and inconsistencies. As a result, many complex structural components, such as compressor blades, are still made for metal. We have just done something that has never been done before and have developed a new manufacturing process to change this. And we tested our composite blade inside of a fighter jet engine at full power. Our new manufacturing process can produce complex parts at 10 to 100 times the speed of traditional manufacturing, allowing us to be more than 5 times cheaper than titanium at scale. And we have better than 20 times better thickness consistency than traditional manufacturing. Compared to our competition, we have the fastest part production rate at scale. We also have high temperature materials and large part capabilities, allowing us to reach many more applications than other composite startups. Large equipment manufacturers actually want to work with us, and we have received purchase orders from large aerospace primes. Composites is a $200 billion market that will reach $500 billion by 2030. The complex and lightweight structural parts market is over $100 billion, and the compressor blade market is $10 billion. Our compressor blades will increase the efficiency of non-nuclear Navy ship propulsion units, which for the warfighter means less logistical demand for transporting fuels, less fuel expenditures, and less emissions, supporting the Sustainable Infrastructure and Green Technologies Challenge Statement. Our team is well qualified to scale this tech. Brennan and I have 10 years of composites experience. Rahul Singh, our Chief Growth Officer, is a U.S. Marine veteran, former Amazon VP, and was a Los Angeles Regional Engagement Principal at the Defense Innovation Unit. Craig Ellis, our principal engineer, is the former director of composites manufacturing for the B-2 stealth bomber and the former chief technology officer of Northrop Grumman. We are also being supported by a strong board of advisors, including 3-star general and former CIO of the U.S. Air Force, Bill Bender, multi-billion-dollar exited founder Jack Barron, Stanford professor and director Fukuo Chang, and distinguished UC Berkeley professor Robert O. Ritchie.
Together, in just 2 years, with $350K, we filed an accelerated patent application, partnered with a world-leading composite material supplier, and successfully tested our composite blades in a fighter jet engine. We have 2 more scheduled pilots, where our customers will commit over $100K in testing costs and risk more than $10 million of capital equipment. After our initial jet engine test, we came out of stealth and gained significant traction. This includes with the top 5 largest defense contractors. We were part of the FedTech Northrop Grumman Technology Accelerator and are quoted as a success story on their website and LinkedIn. We also received a letter of support from one of these primes, supporting our efforts to join this accelerator, and these primes have provided internal research and development funding to help further our development. We have also received support from Space Systems Command, the Air Force's Autonomous Collaborative Platforms Manufacturing Lead, and are developing lightweight composite 155mm artillery shells for U.S. Army applications to solve the munition shortage, increase lethality, and reduce logistical constraints. For the warfighter, this means that they can take more shells into battle at once and need to fire less of them to have the same lethal effects, significantly enhancing survivability and effectiveness. We've also been part of other extremely competitive accelerators and pitch events. Specifically, Ventures for Climate Tech is funded and backed by New York State. Out of over 300 companies that applied, we were one of 10 selected to receive maximum non-dilutive funding, and the only one to have received a personal angel investment from the program director, Jack Barrett. These opportunities typically have 5 to 10% acceptance rate. To date, there's not a single accelerator or pitching spot we've applied for and not gotten into. Building on our massive traction, we've raised a $3.9 million seed round to rapidly scale. In the past 2 weeks alone, we built our first artillery shell prototypes, and we also built our 25-foot, 12,000-pound steel skid to serve as the base for our large capital machinery. We would love to have your support as we revolutionize lightweight component production. Thank you.
Quick question for you. This is Marco at the Naval Postgraduate School at Tech
Hey,
Bridge.
Marco, sorry, let me hop in real quick.
Yeah, sure.
This wouldn't be a Zoom event without some technical difficulties. For some reason, our speakers aren't able to accept the promotion to panelists, so they're not able to come off of mute. So we're going to continue to work on this in the background and try to figure out what's going on. But for now, we're going to go forward without Q&A. So unfortunately, thank you guys for your flexibility. Thanks for understanding. We've been doing this for a few years, and Zoom still finds a way to trip us up. So we'll keep working on this, and hopefully we'll be able to circle back to Q&A with all of these companies.
So Brady, I'm sorry, should we score the company now or wait to do it?
Let's go ahead. Let's wait, and then we'll be able to know by the end if we have it. And then if we do not have time for Q&A, we'll leave a little bit of extra time for you to submit your scores. So maybe jot down your thoughts while they're still fresh. You can have kind of a tentative score, and then hopefully we'll have a Q&A to get some more clarity.
Okay, yep, that's fine. Great, thanks.
And judges, I'll give you some time to jot down your scores. Moving on to Superfoam, high-performance foam materials for defense and safety.
Hi, I'm Zeph, CEO of Superfoam, and I'm excited to introduce a breakthrough in impact and vibration protection. For decades, foam has been the go-to solution to safeguard people and equipment. But traditional foam simply isn't keeping up. Take the NFL, for example. In 2022, there were 149 concussions, up from 126 the year before. And across industries, vibration damage is quietly shortening equipment life, driving up maintenance costs, and causing critical delays. That's where Superfoam comes in. Our patented material absorbs twice the impact energy and reduces up to 6 times more vibration than conventional foam. How? Through a revolutionary microcell structure. While most foams are either open cell, like a dishwasher sponge, or closed cell, like helmet padding, Superfoam uses a semi-closed cell design, engineered for superior energy absorption and flexibility. And it's also 12% lighter. This chart shows the difference. The green curve is a typical impact with no foam, short and sharp. Superfoam extends the duration of the impact, meaning it dissipates force more gradually, reducing risk and damage. Our results have been independently validated and published in leading scientific journals. And we're already working with forward-leaning companies, including on a project to protect spent nuclear fuel, proving our foam's capabilities under extreme conditions. The total addressable market is massive. Foam is used in nearly every industry. We're starting with aerospace, automotive, and defense, with a modular foam pad designed for flexible integration into current systems. But performance isn't the only thing we're changing. Traditional foam manufacturing is multi-step, energy intensive, and wasteful, producing 30% scrap, uses harmful PFAS chemicals, and polluting industrial ovens. In contrast, our two-step process is cleaner, faster, and highly scalable. It reduces production steps and enables on-site manufacturing. We supply the polymer mix, and customers produce foam as needed. No waste, no long lead times. This flexibility supports just-in-time logistics and improves readiness, especially valuable in lean manufacturing environments. We're not going up against just competitors. We're challenging an outdated model of manufacturing and delivery. Legacy suppliers rely on large minimum orders and centralized production. Superfoam is modular, distributed, and designed for next-gen supply chains. So far, we've raised $175,000 in non-dilutive price funding. Manual production begins in just a few weeks. We're also pursuing R&D grants to accelerate our automated systems, with a pilot due in 2026 and full rollouts expected by 2027. Behind Superfoam is a world-class team. My name is Zeph. I'm a serial entrepreneur with deep experience in product design and manufacturing. Professor Yusuf is the inventor of the foam and a globally recognized polymer scientist. George brings decades of manufacturing operations expertise, and Jadamis is our industrial automation specialist. We won 3 innovation awards and will receive the Spheres of Sustainability Award later this April. We're here today to connect with partners who are serious about advancing protection, resilience, and sustainability in high-impact environments. Thank you, and we look forward to building the future of protection with Superfoam.
Hey, judges, just an update. We're still fighting with Zoom. We don't know if it's going to let us go. I'd say for now, let's go ahead and submit scores. So in this time, you can go back and submit for the previous company, and we'll submit scores going forward. And then, yeah, it looks like we're probably not going to be able to do Q&A. So let's go forward, assuming that we cannot.
So no Q&A on this one either.
Correct. For the whole accelerator. We don't want to give some people Q&A and some people not Q&A. So in the interest of fairness, we're just going to kill Q&A for Accelerator.
Yeah.
Since Igniter all got Q&A, that's fair, but we want to make sure we're fair here.
Copy. So Marco broke the Q&A by asking questions too quick.
Yeah, that sounds about right for me.
Marco.
Polo.
And judges, I'll give you some more time here just to finalize your scores for the first and second team. Next up, Roboto AI, building AI tools for telecoms, information sharing, and injury prevention.
Hi, my name is Benji Barash, and I'm the co-founder and CEO of Roboto AI. Thanks for your time today. As I'm sure you're aware, the robot revolution is finally here. Thanks to recent breakthroughs in sensors, GPUs, and autonomy, robots are transforming nearly every industry. This shift is going to be truly transformational. Just last week, NVIDIA's CEO Jensen Huang called robotics the next multi-trillion-dollar industry. This all sounds great, but there is a problem. During operation, robots generate logs. And these aren't just normal system logs, they're packed with multimodal sensor data. A single robot log file can contain gigabytes of this data, ranging from camera images to LiDAR point clouds and more. As you can imagine, during operation, even a single robot can generate terabytes of logs. And within those logs, there can be critical errors or edge cases that need attention. Unfortunately, the problem only worsens as the number of robots increases. When you scale to a fleet, the volume of log data becomes truly overwhelming. We call this robot log overload. Engineers and operators struggle to analyze the massive amount of data, and it's impossible for humans to review it all. As a result, most logs are ignored unless something obviously bad happens. This means problems and edge cases often go undetected until it's too late, posing significant safety and reliability risks that compromise robotic deployments across nearly every industry. 2.5 years ago, we set out to solve this problem. We asked ourselves, what if analyzing log data could be much easier for everyone? What if searching for edge cases in logs could be fast and intuitive? What if decision makers could get time-critical insights powered by AI? And that's exactly what we've built. Roboto is an AI-powered platform specifically designed for robotics data analysis. We help organizations manage their robotics sensor data with first-class support for standard robotics data formats, and we can even support proprietary ones too. Our platform then simplifies log data post-processing and even makes it possible for AI to surface critical issues and events. Here's a screenshot of Roboto analyzing a log file from an unmanned aerial vehicle. On the left, you can see that Roboto has detected high vibration and air traffic warnings in the log data. These might have seriously compromised the mission. An engineer or operator can then click on these events to investigate the issues, replay the data, and assess the impact. We also leverage powerful AI to find patterns and anomalies in logs using our patented signal search technology. This allows engineers and operators to ask critical questions like, have we had this issue before? Is it an anomaly? Is it impacting a single robot or the entire fleet? And you can even set up alerts to get notified if an issue happens again. We built Roboto with dual use in mind. It's already deployed in GovCloud at IL4 and IL5 for secure use, and it's actively being used by commercial customers building autonomous vehicles and drones. Roboto helps to maximize mission readiness and reduce lifecycle costs for autonomous systems. More importantly, it enhances decision-making with advanced sensor data analytics. This improves operational availability and can power predictive maintenance workflows. Over time, Roboto can preempt system failures like motor degradation and detect anomalies before it's too late. Robots and autonomous systems are going to be everywhere. We see the robotics industry growing to over $1 trillion by 2035, given global labor shortages, and a massive push for autonomy with the emergence of edge AI. We see a $3 to $10 billion SAM focused on providing this core data infrastructure, and Roboto is positioned to capture $10 to $50 million in near-term ARR. We think there's an amazing opportunity to partner with leading manufacturers, as well as cloud providers, and all of the DoD commands and labs that are now making large investments in autonomous systems. As robotics adoption grows, we will then expand our footprint, unlocking even more of the SAM and positioning us to scale with the market. And we have a big leg up here because we're the first to market with a comprehensive robot log analysis platform. Traditional data platforms are built for tabular data. They can't store, process, or analyze multimodal sensor data. Meanwhile, companies that do work with sensor data have mostly just focused on visualization and labeling. We're the first to build a platform that makes robotics data searchable and analyzable at scale. And we have an amazing team driving rapid innovation in this space. Our founding team came from Amazon Robotics, working on drone autonomy and simulation, as well as work at AWS on Project Maven. Roboto was incubated at the Allen Institute for AI, alongside top researchers in machine learning, computer vision, and NLP. Since then, we've raised $4.8 million in venture capital from leading investors in the Bay Area and Seattle, and we've protected key innovations with patents. We've also deployed Roboto for some amazing customers. Thank you very much for your time. We can't wait to unleash the full potential of robots and autonomous systems through log-driven intelligence.
Judges, please take a minute to fill out your scorecards. Next up, Chasm Labs, developing simulation and communication platforms for contested environments.
Hey everyone, I'm Jim Razmitzis from Chasm Labs, and I'm excited to introduce you to K10, our tactical edge network. In remote and contested environments, whether it's city agencies coordinating relief efforts or warfighters under pressure, reliable, secure connectivity often spells a difference between smooth operations or total chaos. K10 provides you the right size network, not a carrier-scaled solution that is as bulky as it is pricing. Now you see, traditional cellular systems are built for big carriers. They're closed, they're expensive, and they're about as user-friendly as quantum physics. Add in crisis scenarios or disaster response, and these black box networks slow down crucial coordination. No one should have to be fumbling with complex hardware or vendor lock-ins when every second counts. We tackled two Crucible challenge statements head-on: telecoms and information sharing by enabling multiple agencies to interoperate seamlessly, and injury prevention and safety through real-time data sharing that helps first responders and warfighters avoid dangerous blind spots. With K10, everyone stays in sync, which translates directly to fewer mishaps and safer teams. So how do we do it? Well, we start with edge computing. We run all the core network functions and critical apps on here locally. We have no cloud dependencies. Secondly, K10 includes its own self-contained Grandmaster clock. So we're not tethered to GPS signals that can be jammed or just unavailable. There is no huge deployment team required. This whole system boots up in less than 10 minutes. And finally, we have our single all-in-one G-Node B, which means less hardware clutter, more simplicity, and we can literally fit this into an overhead bin of an aircraft. That means it's lightweight, it's durable, and it's ready for field action. Now, don't let this size fool you. Size it up or size it down. We can cover a single outpost or hundreds of acres. No forklift upgrades required for this system. Now, compare this to Ericsson, Nokia, and Solona, and we do love them. K10's major difference is its simplicity and its true openness. We are not a lumbering aircraft carrier. We're a fleet of agile, mission-tailored vessels. Our edge computing and easy operations cuts through common pain points. No external timing, no vendor bloat. It's private 5G that's lean, and it's mean, and it's built to adapt. Now, K10 isn't just a theory. It's already powering real missions. We are actively piloting K10 operating in a drone 24 hours in a day, flying at 5,000 feet and providing 5G coverage. We were first place in Ensign's Catastrophic Communications Challenge in June of last year, and we run private large networks for the Port of Tacoma. If this works for busy ports and the Air National Guard, my friends, imagine what it can do for your urgent disaster response or cross-county collaborations. Now, our vision was centered on a multi-domain of connectivity, land, sea, and air, where K10 delivers real-time command and control and across advanced vehicles, naval fleets, and UAVs. This is not only streamlining information sharing, but it's also helping teams keep safe. Think of having eyes and ears everywhere, minus the steep learning curve. Now, we lived by 3 core solution pillars. It had to be deployable, it had to be open, it had to be flexible. K10 merges standalone 5G with edge computing for secure and nimble networking with no vendor lock-in, no insane price tags. It scales exactly as your mission demands without turning into a giant money pit. Now, the private 5G market is exploding. It's forecasted to have a 53% CAGR and hit well over $10 billion from 2030. We've already have 13 clients in production covering over 500 acres and counting. With a pipeline north of 1.3 million just this year alone, we see the market. We typically come in at about 83% cheaper than the incumbents, and for agencies running on tight budgets, that's more than a footnote, my friends. That is a lifeline. Now, while we can't share too much, I can say that we've been involved in several U.S. federal and state agencies with K10 as a platform for their missions. In 2023, we signed a CRADA with the U.S. Navy at Keyport, and now we're partnering with the National Lab to enable connectivity for CBP at ports across the United States. K10 is unlocking platform potential in an open way, helping these agencies do more with 5G. Now, behind K10 is a team of industry pros from Microsoft to Cisco and AT&T. Even Scott, our CTO, is a former volunteer firefighter, giving us real insights into his emergency scenarios. We've built everything from massive data centers to deserts to wireless clouds for fully automated facilities. Suffice to say, we're comfortable handling big tech challenges so you can rest easier in the field. And so with that, in closing, thank you for hearing us out on K10 and how it's helping redefine how agencies and defense units approach telecoms and information sharing. We appreciate it, and have a great rest of your day.
Judges, please take a minute and fill out your scorecards. Up last, GlowSense LLC, creating low-cost sensing platforms for injury prevention and directed energy detection.
Hi, I'm Noah from GlowSense, and we're here to help bring injury prevention and safety to our directed energy workforce. I'm a former Navy civilian directed energy professional with experience in technology transfer. My co-founder is a former captain of Marines with operational experience, and our advisor designs economic models of safety in aerospace operations. We have research institution partners on both coasts that specialize in directed energy and in safety. GlowSense is responsive to the Inland Empire problem sets of directed energy and injury prevention and safety, as well as the naval problem set of advanced measurement and metrology. These problems are being experienced regularly by our directed energy professionals. Everyone in this field has a story about accidental or confusing high-power microwave exposures that caused harm to people, equipment, and to the delivery of critical directed energy systems. Our nation's directed energy enterprise spends $2 billion per year and is operating at absolute maximum capacity and effort. Accidents, errors, unintentional exposures, and other safety hazards have severe consequences when using microwaves. Mistakes can bring a lab's work to a halt, ruin schedules and elevate costs, and harm people and equipment. The Navy and DoD have been constantly searching for new microwave measurement and detection solutions. Many different SBIR research attempts, for example, have been made, but the directed energy workforce is still trying to deliver at maximum speed and capacity in an environment of uncertainty. The good news is that we at GlowSense believe we found the solution in the form of a U.S. Navy patent. It's a special glowing paint. When microwaves are present, the badge lights up and glows. No electronics, just paint. Navy and DoD have continued to ask for disposable directed energy measurement solutions. And now that we've established a license agreement with Naval Surface Warfare Center Dahlgren, GlowSense is positioned to deliver. With this Navy technology, we can have a microwave badge. In the past, coal miners used canaries to detect low oxygen, and now GlowSense offers a badge to detect microwaves. Now we can protect the directed energy workforce and safely operate our microwave systems with confidence. There is nothing else like this on the market. Certainly, there are other ways to detect and measure microwaves. All these methods are reliant on complex, delicate, and expensive electronics. GlowSense is bringing in new benefits to microwave sensing that we've never had before, including ultra lightweight, durability, disposability, size scalability, and production scalability. Each badge costs less than $1 in materials and manufacturing and can be sold for tens of dollars. We make microwave detection simple, easy, and certain, and this is how we achieve a revolution in the safe operation of directed energy. It's our customer discovery that led us to this microwave badge, and we're always working to have conversations with the directed energy workforce. We've established a cooperative research and development agreement with Naval Surface Warfare Center Dahlgren as a part of our Navy patent license agreement. Laboratory prototypes of the microwave badge have been successfully tested against both Navy microwave systems and commercial microwave ovens. Our growth plan begins by focusing on sales to the directed energy workforce of 16,000 people. These are the people most at risk to microwave exposure and represent a $41 million annual revenue market opportunity. Once we've established ourselves in our nation's laboratories, we will pivot to our deployed U.S. forces and NATO allies to help protect them from accidents with their systems and from attack from hostile systems. We will pivot again towards the commercial market as we develop our total addressable market. Commercial microwave operators need to convince their clients of the safety of their operations, and our tag also meets that need. GlowSense's vision of success is through the pursuit of non-dilutive sources of funding. We've concluded our introductory startup accelerator program prior to FedTech, and we have an NIH SBIR proposal for injury prevention actively in committee review. We also intend to pursue DoD SBIR funding to position ourselves for future sole source justification. Having established the need for a simple microwave detection and measurement solution, we will now begin a process of requirements refinement, creating formal DoD requirements and engaging with defense primes. These requirements will be used to optimize the design of the tag, and then we'll go into production and sales, confident that we are offering the needed and valuable products. Our exit strategy is to be acquired by a prime directed energy supplier. Our ask from this audience is to help us have conversations. We plan to begin attending RF safety training classes as the next step in our customer discovery, and there are also agencies and organizations across the directed energy enterprise that we would love to be able to talk to.
Judges, please take a minute to fill out your scorecards for all the accelerator teams. Please join me in a round of applause for all of today's teams. Your creativity, effort, and drive to solve real-world problems is truly inspiring. To close out today's program, we're honored to be joined by Captain Joel Uzarski, Director of NavalX. Captain Uzarski leads the Navy and Marine Corps' innovation arm, helping accelerate ideas from across the force and build stronger connections with industry, academia, and government partners. He brings deep operational experience as a surface warfare officer and an acquisition expertise from some of the Navy's most critical weapons and combat systems programs. Before leading NavalX, Captain Uzarski served as the Major Program Manager for the Aegis Ballistic Missile Defense Weapon Systems at the Missile Defense Agency. He's commanded at sea, deployed in support of global operations, and held leadership roles across multiple major Navy and DoD acquisition commands. His career reflects a commitment to warfighter readiness, technical excellence, and delivering innovation where it matters most. Please join me in welcoming Captain Joel Uzarski.
Hey, thanks, Jacob. Appreciate it. First of all, I wanted to point out on that picture there that everybody sees online, the best DDG in the fleet, USS Gridley, DDG 101. Stationed up in Everett, Washington. I was up there for 4 years. Love it. I want to go back there. So anyways, thanks, everyone. Good afternoon. I'm Captain Uzarski, Joel Uzarski. I'm honored to be the director of NavalX. It is great to see the Crucible in its second year. This was the first event that I attended when I took over as director of NavalX back last April. And wow, just wow. Congratulations to the entire Crucible cohort. Seriously, job incredibly well done. Hearing the pitches we just experienced, I'm genuinely impressed. The quality of thought, the dedication each team has shown, and the sheer innovation on display is truly remarkable. It's really inspiring to see so many talented individuals, entrepreneurs, engineers, problem solvers, all focused on tackling some of the Navy's most pressing challenges. You've all put an enormous amount of work to get to this point, and it shows. Whether you're an igniter team or an accelerator team, you've demonstrated the courage to step forward and offer solutions, and that's something we deeply value here at NavalX. What you've been building here isn't just about cool technology or potential business opportunities, although that's very, very important. It's fundamentally about national security. The work being done through Crucible directly supports the Navy and the DoD in critical areas: innovation, resilience, and maintaining our technological superiority. Events like this are essential. They aren't nice to haves. They are vital for identifying and accelerating the capabilities that give our warfighters the edge they need in today's incredible, complex, and rapidly evolving operating environment. We need to be constantly looking for ways to outpace our adversaries, and that requires a relentless focus on new ideas and new approaches. Each of you, through your pitches, have contributed to that effort. You've taken on hard problems and you present thoughtful, actionable solutions, and that's exactly what we need. None of this, of course, happens in a vacuum. The success is a testament to the power of collaboration and strength of the ecosystem we're building. I want to extend a very special thank you to Troy and the entire team at Inland Empire Tech Bridge, including FedTech, who helped put this event on into play today. Their leadership and their commitment have been absolutely instrumental in making Crucible a reality. They've done an exceptional job building that critical bridge between the vibrant innovation ecosystems out there and the needs of the fleet and the force. They've been tireless advocates for this program and for all of you. Let's give them another virtual round of applause. Good job, Troy and team. Thank you. The future of naval power isn't about bigger ships or more weapons, although those are very important. It's about our ability to embrace innovation early and to work with non-traditional partners like all of you, and to move faster than our adversaries. That's the core principle behind NavalX, and it's why we're so excited about the potential of Crucible. This event is a prime example of how the Navy is leaning into these efforts, actively scouting disruptive technologies, cultivating partnerships with those who can move fast and think differently, and creating a pathway for those solutions to reach the fleet. We're not just looking for incremental improvements, we're looking for game changers. And I really believe, based on what I've seen today and heard, that many of those game changers could be in this cohort. So as our judges begin the important work of deliberating and determining the final selections, I want to thank you all again, from the organizers and the mentors who dedicated countless hours to making this event a success, to the innovators who poured in their hearts and minds into their pitches. Your work matters. It truly matters to our warfighters, to the security of our nation, and to the future of the Navy. While they're tallying the votes, and believe me, this is looking to be a pretty tough decision, please take a moment to connect with each other in the chat. Share your contact information. Continue building these valuable relationships. It's unfortunate we couldn't be there today in person due to the travel restrictions that have been put on the government. However, there is still a lot to be learned into the opportunities with this event. The network that you've created, that we've created here, is just as important as the funding that are coming out of it. Results will be out shortly. Again, thank you to the entire team. Thank you to everybody participating, and congratulations to everyone involved.
On behalf of FedTech, sir, thank you, Captain Yuzowski, for your thoughtful remarks and your continued support of this community. We're honored to be a part of the innovation ecosystem that NavalX is helping lead. For the award ceremony, I'll be handing it back over to Brady.
Oh, thank you, Jacob, and thank you again, Captain Yuzowski and Troy. We appreciate the support. Well, we've seen great pitches. We've heard from our key partners, and we tackled some technical difficulties together. I'm hearing that this is a nationwide Zoom outage today, just so everybody knows. And so now we're at the moment we've all been waiting for, the awards. For the Igniter cohort, the third place team will receive $20,000, second place receives $30,000, and the first place team receives $50,000. Not a bad start for brand new companies just starting their journey. So, in third place, recipient of $20,000, Ambient Sense Technologies. Big applause for Ambient Sense and their game-changing smart stickers. They're helping protect critical infrastructure with simple, scalable solutions. Fantastic example of innovation meeting a mission need. In second place, recipient of $30,000, Solid Hydrogen. Big congratulations to the Solid Hydrogen team for tackling one of energy's biggest challenges. Their solid state hydrogen solution could transform how the Navy and others think about fuel. And in first place, the recipient of the $50,000 grand prize, SHIELD. Well done to SHIELD for building a powerful defense solution against modern drone threats. Their laser detection system is already proving its value in safety and situational awareness. We're proud to celebrate their success today. So congratulations to the winners and to the entire Igniter cohort. Your progress over the past few months really is remarkable. It's no easy task to start from scratch, and we're really impressed with what you've accomplished so quickly. And on to our accelerator winners. Third place will receive $25,000. Second place will receive $50,000, and first place receives the $75,000 grand prize. In third place, the recipient of $25,000, Roboto AI. Congrats to Roboto for bringing clarity to complexity in the robotics world. Their AI-powered tools are helping operators move faster and smarter. A fantastic effort from a future-ready team. In second place, recipient of $50,000, Hybron Technologies. Big congratulations to Hybron for raising the bar in advanced manufacturing. Their composite solutions are unlocking new capabilities for defense and aerospace. An impressive showing from a high-performing team. And in first place, recipient of $75,000, Chasm Labs. Congratulations, Chasm Labs, for bringing high-performance connectivity to some of the hardest-to-reach environments. Their portable 5G networks are a breakthrough in secure communications. We're excited to see their continued growth. Congratulations to all of you. It's always great to see these cutting edge technologies and hear from entrepreneurs working to support our national security. We hope this funding helps you scale and make the impact that we know you're capable of. Before we go, a couple of quick asks. If you could complete our quick 2-question survey in the chat, and it's available through that QR code. That feedback is crucial and helps make sure that we're delivering the best programs we can. And we'd also like to invite you to watch all of the Igniter and Accelerator pitches from the entire cohort. We had a total of 25 teams across these 2 programs, far more than we could look at just here today. And we've linked everyone's 5-minute pitches in the chat and in these QR codes as well. On behalf of everyone at FedTech, NavalX, and the Inland Empire Tech Bridge, thank you. To our judges, our partners, and especially our teams, this event is a celebration of your hard work and commitment. The pitch competition ends today, but your innovation journeys are just beginning. We can't wait to see where you go next. Thank you all for joining us. We look forward to seeing you all next year. This concludes today's program.